Happy birthday to you. Happy birthday to you. Happy birthday, dear Shaylin. Happy birthday to you. Thank you. Also, thank you for the delicious treats.
Thanks.
It's nice when people have birthdays and bring you things, right? Pretty great. Okay, here we go. Today we are starting angle proofs. Again, segment proofs was really weird. We were just trying to hunt, figuring out how they got their next reason or how they got their next statement. I'm trying to figure that out. We're kind of going to do the same thing today with angle proofs, but we're not going to get quite so far because it's a half day, so we're just going to talk through some of these things. This, you can see here, is a reference sheet for angle reasons, so to speak. We have all the properties of equality that we've been talking about. We use all of these with congruence as well. They work kind of the same, which is kind of nice. All right, so we have the definition of congruence again for angles, just like we had it for segments. So we're transitioning from equal sign to congruence. And you can see when we talk about the angles being equal, what does the little m stand for? Measure. The measure of the angle is equal to the measure of angle B. And that's important so that we're communicating to people who are reading our work. We're talking about the actual measure of the angle, how many degrees is the angle, and then we can drop it when we talk about congruence. A right angle, definition of right angle. If an angle or an angle measures 90 degrees, if and only if, there's that biconditional, if and only if it is a right angle. So you can see she used her little biconditional arrow here. So if an angle measures 90 degrees, then it's a right angle. So we could maybe even tighten that up. We could say 90 degrees implies right angle. Hey, that's even shorter, right? So I've got that 90 degrees and the double arrow, right angle. That is the definition of right angle. So you could use this reason. This is a good reason definition of right angle, or we could just write it out. 90 degrees. Double arrow, right angle. 90 degrees means it's a right angle, or vice versa. Okay, it's kind of nice. Complementary definition. What does it mean to be complementary?
90 degrees.
They add to 90 degrees. If two angles are complementary, if and only if, there's that double arrow again. The sum of their measures is 90 degrees. Again, this is a great way to write it out so it has meaning instead of just saying definition of complementary, but either one would work. Complementary, double arrow, sum to 90 degrees or whatever. All right, so that's a good way to write it, a nice short way. Complementary means they add to be 90 degrees. Supplementary, what does it mean? They sum to be 180. Again, the definition is two angles are complementary if and only if their measures sum to be 180 degrees. What's an angle bisector? It splits the angle into two equal parts. An angle bisector splits an angle into two equal parts. That is the definition of an angle bisector, which is kind of nice. It's very much like a midpoint. It splits the segment into two equal segments. All right, definition of perpendicular. What does it mean to be perpendicular? They form right angles, yeah. And again, we can tighten that up. We could say if perpendicular, then we have right angles. And we can probably do a double arrow there. Perpendicular implies right angles, and right angles implies perpendicular. So that is a double angle as well, or double arrow as well. And again, you can say definition of perpendicular. That's a good reason. Or we could just write it like this. Perpendicular means right angles, okay? Or vice versa. Right angles means perpendicular, backwards and forwards. Okay. We have the angle addition postulate. What's that? Well, not half and half. That's very specific. But little angle plus little angle equals the whole angle. If it was an angle bisector, you could say half plus half equals whole. Yeah, if it got bisected exactly in half, okay? So little piece plus little angle plus little angle equals the whole angle. That is our angle addition postulate, just like our segment addition postulate. Very easy. We also know a bunch of other things. Can you believe how many things that we've learned in this month? Like, we've learned all of these things. So this is like just review. I think it's a lot. It's really, really good. Vertical angles. Vertical angles, we have two intersecting lines. And we have numbered angles, let's say, 1, 2, 3, and 4. What angles are vertical angles? 2 and 4. Yeah, angle 2 and angle 4. Angle 2 is congruent to angle 4. Good. What other angles are vertical angles? 1 and 3 are also vertical angles. Angle 1 is congruent to angle 3. So just in case you don't remember what that looks like, we have two intersecting lines. It creates vertical angles. Vertical angles are congruent. We can write that. Vertical angles are congruent. We could write it like that if we wanted to be real short, concise, and descriptive, all in one. That's what we like. Or we could use the vertical angles theorem. Okay, so these are the same thing. I personally like this one the best. Vertical angles are congruent. Okay, that's the easiest. I like it better than vertical angles theorem, which doesn't tell us a whole lot. Okay, but they are the same. The complement theorem, this is an interesting one. If two angles form a right angle, so here I have a right angle and I have now two angles, angle 1 and angle 2. Two angles form a right angle. If two angles form a right angle, what must be true?
They equal 90.
They are complementary. Yeah, they would sum to be 90 degrees. Yeah. So this is the complement theorem. If two angles come together and form a right angle, then they are complementary. And that's called the complement theorem. All right. So we also have the linear pair supplement theorem. So linear pair, if two angles form a linear pair. So what does that mean? What is a linear pair? So they have a straight line, linear pair. So we have a straight line. And then we now have two angles that form a linear pair. So here I'm going to put in here. There we go. Here's angle 1 and here's angle 2. If I have angle 1 and angle 2 and they're forming this lovely linear pair, what must we know about angle 1 and angle 2? They equal 180 degrees. So the measure of angle 1 plus the measure of angle 2 equals 180 degrees. So that is the linear pair supplement theorem, which is kind of a long name, but I like that it's descriptive. The linear pair, so that's if we have a linear pair, then they are supplementary. So those two words really help us out there, okay? Got a linear pair, then they're going to be supplementary. All right, beautiful. We also have the congruent complements theorem. If two angles are complementary to the same angle, then they are congruent. Congruent complements theorem. We haven't talked about these. We also have the congruent supplements theorem. I'm going to talk about that one first. So, for example, I'm trying to think of a picture. for this. So I guess I could do it this way, maybe. Okay. Here is angle 2, here is angle 1, and here is angle 3. And angle 2 and angle 3 are they? Angle 2 and angle 3 are congruent? 1 and 3 are true. We know that because they're vertical angles in this picture. This is not a picture that talks about everything, but it'll work. Angle 2 and angle 3 form a linear pair. Okay, so let's talk about that. That means if angle 2 and angle 3 form a linear pair, that means the measure of angle 2 plus the measure of angle 3 equals 180 degrees. Now, also, angle 2 and angle 1 are also a linear pair, which means they also equal 180. So the measure of angle 2 plus the measure of angle 1 also equals 180, okay? I don't have an angle 4. Okay, so here's what happens. If two angles are supplementary to the same angle, then they must be congruent. So you can see we have angle 3 and angle 1 that are supplementary to the same angle. Watch what happens. I want to get the measure of angle 3 by itself. If I want to get that isolated, what do I have to remove? The measure of angle 2. So we would have the measure of angle 3 is equal to, I'm going to subtract the measure of angle 2, 180 degrees, minus the measure of angle 2. So that's what angle 3 would equal. I want to do the same thing with my red line here. I want to get the measure of angle 1 all by itself. What do I have to do? Subtract the angle 2. So the measure of angle 1 would equal 180 degrees minus the measure of angle 2. Wait a minute. Aren't these the same exact thing? Okay. So if these are the same exact thing, what does that mean about angle 1 and angle 3? They're also the same thing. Okay. So that's the reason, the math as to why, if we have two angles supplementary to the same angle, then those angles, angle 1 and angle 3, are congruent, okay? Because if you do the math, it makes total sense, okay? So if A is supplementary to B and C, so A plus B equals 180 and A plus C equals 180, then A and C are going to be congruent. So that's the congruent supplements theorem. And the same is true for congruent complements. This is just a little easier to draw for me. If two angles are complementary to the same angle, then they are congruent. So again, if you have two equations that add to 90 and they got the same angle in there, then those other angles also have to be congruent, okay? All right, so those are all the things that we have when we're talking about, oh, I just wrote on the wrong page, man, that's frustrating. Okay, when we're talking about all of our angles here, so we're gonna, again, just try a couple of these and we'll just finish up tomorrow. Justify each statement below using a property of equality, a property of congruence, a definition, postulate, or theorem. If angle C is a right angle, then it measures 90 degrees. How do we know that? Definition of right angle is right. Definition of a right angle, which if we wanted to be really short, we could be like, a right angle implies, a double arrow here, right angle implies 90 degrees. Right angle implies 90 degrees or vice versa. Okay. Definition of right angle. Okay, if X is supplementary to Y and, I bet that's supposed to be a Z. Oh, no, different. Okay. If X is supplementary to Y, and X is supplementary to Z, then y must equal z. What is that? It's the congruent supplements theorem. That's the last one we just talked about, congruent supplements. If two angles are supplementary to the same angle, then they must be congruent. All right. If angle 1, if it looks like this, then angle 1 is congruent to angle 2. What's that?
Congruent.
Yeah, vertical angles theorem, or if vertical angle, if vertical angles are congruent. That's the vertical angles theorem. Vertical angles theorem. Vertical angles are congruent. All right, if the measure of angle P plus the measure of angle Q equals 90 degrees, then P and Q are complementary. How do we know that they're called complementary?
Complement. Because they equal.
They equal 90. That is the definition of complementary. Definition of complementary angles, that they add to be 90 degrees. If angle M and angle N form a right angle, then M and N are complementary. Let's turn the page back. If M and N form a right angle, if they form a right angle, then they are complementary. What's the reason? The complement theorem, yeah. So we're using those things from before. That is the complement theorem, which I really just like, if right angle, then complementary. I prefer writing it out as opposed to just complement theorem. It's not. It's like when you walk up to someone, you should give them a compliment. No, that's not what that means. And that's a PLI, not PLE. Different. Okay. All right. Okay. 6. Given M and L, and then there's this angle 1. So line M, line L, weird, and angle 1. If L is perpendicular to M, then angle 1 is a right angle. Definition of perpendicular. Definition of perpendicular. Perpendicular, again, I like perpendicular implies right angles. That is also an acceptable reason there, but definition of perpendicular. If they're perpendicular, then we got a right angle, and vice versa. All right. If angle W and angle X are supplementary, then you can add them and they equal 180. How do we know that? Definition of supplementary angles. Definition of supplementary angles. All right, number 8. If L is complementary to angle M and N is complementary to angle M. So we have two angles that are complementary to the same angle, then those two angles are congruent. What theorem is that? Congruent complements theorem. Yes, congruent complements. Yeah. Theorem. It's kind of nice, when you read carefully, we're using those big vocabulary words in our reasons, right? We talked about perpendicular, so definition of perpendicular. Here we have complementary, and we have congruent, so that's the congruent complements theorem. So again, looking for those sort of patterns. Number 9, if A and B form a linear pair, then they are supplementary. Linear pair theorem is correct. Again, if you turn back right here, the linear pair theorem said if they form a linear pair, then they're supplementary. Linear pair supplement theorem. Linear pair supplement theorem. Yeah. Number 10. If angle N and angle P are complementary, then they add to be 90 degrees. What is that? Yeah, the definition of complementary. Then they add to be 90 degrees. Definition of complementary. If complementary, then 90 degrees. Sum to 90 degrees would be even better. And last two here, given the diagram at the right, the measure of JKM, so that's this angle with a star in it, plus MKL, a smiley face in there, equals JKL, the whole thing. What allows us to say star plus smiley equals the whole thing? Angle addition postulate. Very good. Angle addition postulate. Okay, what allows us to say, hey, if our measures are equal, then the angles are congruent?
I was looking at complementary and theorem and definition. They look like
So the difference is the linear pair supplement theorem says that if they're a linear pair, then they're supplementary. The definition of complementary actually goes from that says that complementary means 90 degrees. Okay, so linear pair gets some supplementary, but is that what you said? But complementary is not. Say it again.
I said the complementary theorem and the definition of complementary.
Okay, so the complementary theorem, right here,
Yeah.
number 5, and then definition of, so number 5 and number 10. What's the difference here? The complement theorem compares right angles being complementary. So if they're right angles, then they're complementary. But the definition of complementary actually means that they sum to 90 degrees. So they tell us that complementary means that they're going to add to be 90 degrees. And so, yeah, it sort of seems like if they're right angles, could they then get to 90 degrees? We have to do it in 2 steps, actually. Yeah, which is, yeah. Interesting. All right, ladies and gentlemen, thank you very much. We will finish this up mañana.